is another big problem that the public is facing, the societies are facing, is what about the end of life of all these products? Waste has become today's wealth, actually. But we have to, real research should go in understanding how can the waste be used for the production of recycled materials, and is there any kind of methodology where waste can be used in order to get energy out of it. And there is a lot of research again that's contributing in that particular sector. Now these three different development challenges implies that conservation of non-renewable or mined resources is required. We have to conserve, we have to control the mined resources, efficient utilization of renewable energy or resources. In the context of future generation, consideration should be given to the usage of 3 planetary assets, and that is given by the United Nations of Center for Human Settlement. And what is that? Finite stock of non-renewable material resources is available. Finite stock, limited stock. And on the other hand, you have this renewable resources and the capacity to absorb pollutants by products of human development. I would like to give you this beautiful example of Yemen, where they have built all their particular living societies. Okay. Society with raw earth. The complete society of this particular thing that I'm showing you is from raw earth, which means it is nothing but pure earth. Okay. So this is another hidden architecture which this particular site has not got a heritage, the tag, because of the other possible problems that are erupting in that case. These earth blocks are made without processing, in the sense they are not burnt. None of the structure, if you see the last picture over here, if you can see me moving, this is the particular society of Yemen, and this is called as Shibam. What is this? In the sense, it has this particular boundary line, right? Can you see that? Though that is the wall that is completely constructed throughout the thing, because they are, that is the wall that is safeguarding the people of this particular society from attacks. These structures have around 6-story building, and people are still living very comfortable in terms of climate, in terms of the indoor air quality, and in terms of the settlement. Location of this place is almost like a desert. You can see the in and around of the particular society. The rainfall intensity is very low. They get only around 2 inches of rainfall, and that is exactly why this particular material can be used over there, and the rain damage does not cause much problem to the pure earth, that is pure earth based structure over here. So that kind of rainfall is what they are receiving, and they are thermally very comfortable. Though they are placed in such arid conditions, thermally they are very comfortable, because this earthen structure has the capacity to insulate the building and provide ambient temperatures to the inhabitants of the building. I'll just tell you why I'm showing this example. So now let's see the other example of Mysore Palace. Over there it was completely earthen structures made out of pure earth without burning the material, using the pure earth as it is. And over here, Mysore Palace, It is all made using natural and local materials. And there are hardly any kind of imported material in this particular structure. Except for they'll have these pillars. All the pillars are cast iron pillars. And initially the palace didn't have any kind of air conditioning system. It was passively conditioned ecosystem. What is passively conditioned ecosystem? Sorry. Which means it was so designed that you really don't require air conditioning. Okay. Now, these examples are something that I'm showing you just for you to understand what kind of design element, what are the things that nowadays architects and engineers need to imbibe in their design analysis, and what glass-cladded modern buildings. Now this has become very common, and I guess this is also becoming a trend to have glass-cladded buildings. You see this particular building in Beijing, Greenland Center. It literally has a kind of overcoat completely covered with glass, right? And here, see all, wavy GT Tower. And this is again completely glass-cladded. The temperature in winter in these two particular places reaches sub-zero temperatures. So what happens is, during the day, the building traps heat present, okay? It traps it and helps in conditioning the spaces inside and provides natural heating to the inhabitants inside. And they provide natural heating, they are reducing on cost, they are not polluting the environment, and they are also having a long-term economic growth because of this. Because they don't have to put any kind of heating system when it goes to sub-zero temperatures. Energy is completely conserved. So reduce energy, reduce emission, and reduce cost. This is their main concept. And similarly, you see all the buildings, almost all the buildings in US also use the same concept of having the glass-cladded buildings. Over here also what they're doing is they're literally harvesting the solar energy to its maximum potential and helping the building ecosystem to be self-sustainable. This is what the whole thing is doing. The whole ecosystem is doing. Let me give you some modern buildings in India. This is Techno Corporate Office in Chennai. I am sure most of you might have seen this place. This is Bangalore, this is Mumbai, this is Westgate, Ahmedabad, Pune, Infosys campus, Jaipur, Guwahati. All are, I just took one picture to show you what this particular thing, glass-cladded buildings. If you guys happen to go outside, you just keep in mind to just count the number of glass-cladded commercial buildings, office buildings, especially these IT people have some kind of, the IT designers, they put the glass and feel that gives some kind of luxury element. I can't understand the understanding of the designers of those particular things. Building climatic zone of India, if you just see the climate zones of India, see the lighter yellow, it says hot and dry. This light yellow, it shows hot and dry climate. Okay, and this one is a composite. This red one, everything is hot and humid. Okay, hot and humid. This is the blue one is the cold one, and green one is the moderate, and where Bangalore is moderate. Okay, So that is why Bangalore has beautiful climatic conditions. What do we understand from this particular map? Buildings in the place where temperatures are more than 38 degrees or anything more, or even 35 degrees itself, we are not supposed to use any kind of glass cladded and glass cladding itself, because they are going to harvest energy from the solar system. The work of the glass is to trap the heat, and what it does ultimately, it heats the building, and then it makes it non-livable for the occupants inside the building. And then what we do? We fix an air conditioning system, super air conditioning system that also what? Not one or two. It's not going to suffice, because all the commercial and these IT buildings are only converted into this glass cladded. So that big envelope, building envelope, needs to now remove the glass, remove the heat that was actually harvested by the glass, remove that heat and put it back to the environment, where we are going to pollute the environment. For that, we are going to fix air conditioning system so that it becomes cool and so that it becomes livable inside the system. We are harvesting the solar energy, we are spending money to remove the heat from inside the building, and then polluting the environment and making it easy for the people to stay inside. So this is the information, thought process I wanted to give. So buildings, either it is conditioned or unconditioned. Conditioned, passive conditioning. Passive conditioning is what we saw in Mysore Palace example, where the design itself is such that it gets passively conditioned. Active condition is putting the cladding and then removing the heat from inside by installing your air conditioned. Unconditioned buildings are also there. Unconditioned buildings mostly are seen in all village areas. Now also, if you see, village areas are so cool, so livable, and they don't really have any kind of degrees, or they don't have any great engineers. They build their own houses. Now villages are drastically changing into suburban and urban, but if we go into the core village places, we still have masons, the village people itself having that particular knowledge which they have harvested from their ancestors. They know what to build, how to build, and what kind of conditioning do they require. And now, when it comes to buildings, it is about conditioned, unconditioned, and also what the building consumes and what the building generates. What the building consumes, it consumes material and energy resource. What does it generate? It generates waste in the form of solid, liquid, gaseous. And what it also generates? Greenhouse gases. Now, what has to be addressed? Availability of material and energy resources. Minimizing pollution. Is that possible if hydrogen gas, hydrogen generation fuel, hydrogen fuel is getting if it's going to be available in another decade or so, or even earlier? Minimizing pollution, yes, it's 100% possible. Waste management, yes, there's a lot of research that is going in to find the methodologies where we can use the waste in order to build houses itself, how you can recycle them, how you can refurbish them into a different product. So all that is also going. And environmental consonance. Now, this is to give you a scenario about global resource consumption. Okay? The type of product, this is something that will make each one of you to think. What is that we are heading to? It is very important for all of us over here, all our great civil engineers here. We don't really just have to come and teach what is there in our books to the children. Yes, that is very important, commendable, very good. At the same time, instill the thought process for the coming generations, and also take up projects like how are we going to change this scenario. It's very important. Food grains production is around 0.35 tons, and this is annual consumption. So it is per capita per annum. Okay, per capita per annum consumption is food grains. So each one of us, this is global resource consumption. India is, if you see Indian numbers, it's somewhat similar or it goes in the same trend. It doesn't differ drastically from this particular numbers, and this is 2017, way back in 2017, the numbers that I'm giving. Right now a lot changes would have happened. I don't have the updated numbers. So the food grain production is 0.35 tons per capita per annum. Cement production is double the amount of food grain. So can we understand? Cement production is 0.73 tons per capita per annum. Now you see a mind-boggling number of, this is 2015 ka number, 6.54 tons per capita per annum.